class. Today we will discuss on the following topics. The first topic would be the continuum. How do we define continuum? Thereafter, the different properties of the materials. It can be the behavior of the materials can be elastic. It can be inelastic. Third will be the isotropic continuum. The fourth one will be the anisotropic continuum, and the fifth one would be the homogeneous continuum. Let us first define the word continuum. A continuous sequence in which the adjacent elements are not perceptually different from each other, but the extremes are quite different, are defined as the continuum. Over here, in this case, in the subjects of advanced solid mechanics, we will consider our elements to be continuum. The behavior of the materials, the behavior of the continuums can be linear and it can be elastic. It can be non-linear and elastic. When we will say that the behavior of the materials is linear and elastic, when the loading graph, this one is the loading graph and this one is the unloading graph. When the unloading graph exactly retraces the loading path, then we will say that the material is linear and elastic. The second one is the non-linear and elastic behavior. In this case, the behavior of the materials will be non-linear and inelastic. Why? Because this plot itself is not linear. It is not a straight line path, but the loading plot. So this one is the loading plot, and this one is the unloading plot. This unloading path retraces the loading path, but it is not in a straight line. Then this types of the material is known as the non-linear elastic material. Now the different behaviors of the materials. The behavior of the materials can be elastic and the behavior of the materials can be inelastic. These three plots, this plot, this plot and this plot represents the elastic behavior, whereas the elastoplastic behavior is represented by this elastoplastic behaviors are represented by this plot and this plot. So when we will say that the behavior of the material is elastic, when the loading plot, this one is the loading plot and this one is the unloading plot, when the loading and the unloading plot is linear and the unloading plot retraces the loading path in a linear manner, we will say that the material is linear. The second type of the plot can be non-linear. Why non-linear? In this case also the loading plot and the unloading plot retraces its path, but the plot itself is not linear. In that case the material will be non-linear elastic materials. The third type of the behavior is a cyclic loop. So when the loading plot and the unloading plot does not retraces its path, so the area enclosed in this figure would be the energy stored or absorbed by the materials. The second sets of the materials, we classify it as the elastoplastic materials. So in this case the loading plots, after it reaches the yield values, it the yielding after it reaches the yield values, the stresses remains the constant but the strain uh, the increases. Such types of the materials are known as the elastoplastic materials. The second class of the material is with strain hardening. As we go beyond the yield values, there is increase in the values of the stress as well as there is the increase in the values of the strains. Such types of the materials are known as the materials with strain hardening behavior. The other kinds of the materials when it reaches the yields values, the stresses decreases with the increase in the strain. If the plot is of this forms, this is the linear plot and this one is the nonlinear plot, then these types of the behaviors will be known as the materials with strain softening. The other class of the materials can be when the materials is rigid plastics. So the materials is rigid, it will keep on continuing taking the loads up to the maximum values. This thereafter suddenly there will be drop in the decrease in the values of the stress. Such materials are known as the rigid plastic materials. Next is the isotropic continuum. Isotropic means the properties is same in all the directions. Thereafter we will say these things in terms of the engineering parameters. That engineering parameters will be elastic modulus and the shear modulus. So in case of the isotropic continuum materials, isotropic continuum, the elastic modulus is same in all the directions. So it doesn't varies with the change in the rotations of the angle, it is constant throughout. So the second is E is not a function of theta. This means that if it is same in all the directions, then it is not a function of theta. So here we see that if this one is an isotropic continuum, the values of the E, the values of E in all the directions in the three-dimensional space will remain constant. Such types of the materials are known as the isotropic continuum. So we have the directional invariance. So we have the directional invariance both with respect to the properties. The various properties are the elastic properties as well as the with respect to the plane, which is the shear modulus. Anisotropic continuum. An isotropic continuum is a continuum in which the elastic modulus is not same in all the directions. It will have different values in the different directions. So we can say it E, the values of elastic modulus is a functions of theta. If we have a continuum like this, then the values of the E in different directions will be different. Over here the value is E1, in the y direction the value is E2, the values of in z direction it will be E3. The values of the properties of the materials, the elastic modulus is not same in such materials in case of the anisotropic continuum materials. Homogeneous continuum. Suppose this one is a continuum, so this one is a continuum, the entire figure represented by the outer boundary. So in case of the homogeneous materials, the properties, the material properties associated at this location, this small points, and the material properties associated with point B are exactly similar. Both the properties of the materials which we are having at this are exactly similar. So it is written the material properties associated with point A, this point A is very small, and the material properties associated with the point B are exactly similar. This means as if A and point B are exactly similar, this means that the point A is a true representation of such a continuum. This means that the point A, which defines this locations, is a true representation of this entire continuum that we have selected. In such a case, the materials or the behavior will be called as the homogeneous continuum. So the learning objectives for this sessions would be, we have discussed about the continuum. Thereafter, we have studied the elastic and the inelastic behaviors of the materials. Thereafter, we have studied about the isotropic continuum. Isotropic means the properties is same in all the directions. The values with terms of E, the elastic modulus, and the G, the value is the shear modulus. Thereafter, we have studied about the anisotropic continuum in which the values of E is different in the different directions. Thereafter, we have studied about the homogeneous continuum. In this way, this means that the properties associated with a small point in the continuum is a true representation of the entire continuum which we have selected. This is what for this session. We will meet again in the next session. Thank you.